All right, welcome back. We're going to talk about another method here. And this method is coming from section 9.4. And in 9.4, we are going to be solving by a method called completing the square. Okay? And it is a very useful method in very specific cases. It's also the method that we're going to use to convert in between standard form and vertex form. So we're going to do that in class. Um, but essentially, what our goal is to solve x squared plus 6x minus 10 equals 0 by completing the square, obviously. But the reason why completing the square is sometimes necessary is that, number one, if you were to try to solve this by graphing, you would see that it turns out to be two decimal answers. And not just decimal answers, but decimal answers that don't end, and so you would have to round and estimate, and we don't really like to do that. And so graphing isn't going to be a great solution for us. Also, I'm hoping that you see that this doesn't factor. There are not any two numbers that multiply to negative 10 and then add to 6. So it doesn't factor. And we can't use the square root method currently because you've got two x terms here. And remember, square rooting only works if there's just an x squared term. So that's kind of where we're going here. And so I guess the first thing that I want to do is kind of show you visually what we're trying to make happen in this section. Okay, so I've got what's called algebra tiles here. Okay, these are the x squared tiles. So whenever I refer to an x squared tile, that's the big square. These little tiles here, these are the x tiles. Okay, so we've got x squared, and then we've got x tiles. And then these little bitty squares, these are going to be the ones. Okay, and you're like, well, why does that matter? And let me show you, okay? So let's say that we have the situation x squared plus 6x, and I want to represent that visually, okay? So that means that I need an x squared tile, and then I need 6 x tiles. So 1, 2, 3, 4, 5, 6, okay? And I want to arrange these in such a way that we could make a bigger square. Obviously, we start with a square here, but then what we're going to do is we're going to arrange these so that we make the square a little bit bigger. Now, this might not be something that occurs to you right off the bat, but this is the best way to do this, is to put some on the side, some on the bottom, okay? And then if you realize there's no way in which we can order these tiles so that it creates a perfect square right off the bat. You can try it. I'll give you some of these in class. But it's just not going to happen. So our goal is to figure out how many 1 tiles we need to complete this square. And so there's one, here's one, here's one, there's one, here's one, there's that one. Okay, boom, boom, boom. And if you look, it's not perfect, almost. But you would need 9 squares, little squares, to make this a perfect square. Okay, so I'm just going to make note of that, and then we'll talk about what that actually means. But we need 9 tiles to complete the square. I'm going to abbreviate that. Okay? And so what that means is, well, we had an x squared and we had a 6x, but then we added 9 tiles. Okay? And then what's really cool about that is that factors to x plus 3 and x plus 3, which we could then say is equivalent to x plus 3 squared. And you're like, okay, but why? Well, the why is going to come a little bit later in some of our examples. And so let's do another one like that, okay? Let's talk about what if we had x squared plus 2x, okay? And I'm going to put a plus c on the end because we know we're going to need to add some tiles. We just don't know how many. So we have an x squared, and we've got 1, 2 x tiles. So we're going to divide them up. put them on each side, and we realize that we only need one little square tile this time to complete this square, okay? So we say, okay, well then the C value is 1. So then we've got x squared plus 2x plus 1. And then that factors to x plus 1 times x plus 1, which then is x plus 1 squared. So that's pretty cool. Let's see what happens if we have x squared plus 4x plus c. So this time, we need 4x tiles, so 2 on each side. And so we would need 1, 2, 3, 4 x tiles right there. Okay, so c is 4 here. So we've got x squared plus 4x plus 4, which factors 2x plus 2, x plus 2, which turns out to be x plus 2 squared. And you're probably like, is there a pattern? There sure is. Let's keep going. What if I had x squared plus 6x plus c? So, which we actually already did. Let's do 8x, sorry. X squared plus 8x. So that means we have 4 on each side. And some of you probably are already seeing this pattern. So there's the 4x. And then I'm not going to fill in all of these because I don't have that many 1 tiles. But okay, so we're going to be 4 across and we're going to be 4 down. So that means that I'm going to need 16 total little squares to get there. So C equals 16. So that means we have x squared plus 8x plus 16. And that factors to x plus 4, which turns out to be x plus 4 squared. Okay, let's do one more example. So what if I did x squared plus 10x plus c? So that means that we're going to have 5 across, all right? And then I don't have, so we're going to have to problem solve. I don't have another 1 tile, so pretend this is a 1 tile, okay? How many little bitty 1 tiles do I need? Well, I would need 5 across and 5 down, which would give me 25 small tiles. So you're left with x squared plus 10x plus 25. And that factors to x plus 5 and x plus 5, which is x plus 5 squared. Okay? And so now let's talk about the pattern that we see. Okay? First of all, understand that we're going to call the b value, whatever value is right before the x, just like we did in standard form. The c value is the value on the end. That's the value that we found here. But I'm going to actually call this the d value over here, whatever value ends up in this binomial. So the first pattern that I want you to recognize is that we've changed all of these polynomials over here so that they could be factored into a perfect square binomial. Okay, so that's some vocabulary that I do expect you to know. We've already talked about it. The goal is to take it, create a trinomial so that we can factor into 2 binomials. That's the goal of completing the square. Okay, so now let's talk about the pattern between these 2 things. And so I guess the first thing that I want to talk about is this d value right here compared to the b value. So if we're going to compare 1 to 2, 2 to 4, 4 to 8, 5 to 10, I'm hoping that you realize that the d value is equal to whatever the b value is divided by 2. So whatever number we end up out here with this perfect square binomial is whatever the b value was divided by 2. Okay, like 2 divided by 2 is 1, 4 divided by 2 is 2, 8 divided by 2 is 4. And guess what? That pattern is going to continue. Okay? The next one that I want to talk about is then the c value. Okay, so we're going to compare the c value here. Let's compare it to d. Okay? So we've got 1 to 1, 4 to 2, which, okay, so times 2. But then look at this. 16 and 4, 25 and 5, and then even 6 and 9. Okay, what I'm hoping that you realize is it's that number squared. Okay? But because you know that D is already B over 2, you can use substitution. Take whatever D is, plug it in there, and you end up with B divided by 2 squared. And that is indeed how you're going to find the C value every time here. Okay, you're not going to get algebra tiles. You can use them if you wish, but you're not, when you're on the test, you're going to have to use this right here. The knowledge that, okay, well, that, however many squares I would need is going to be whatever the B value is divided by 2 and squared. Okay, now if that confuses you, go back and rewatch that segment of the video. Okay, don't come to me and say, I didn't understand if you didn't watch this at least twice. Okay. Okay, so let's do some examples. I feel like the best way to just really get this is to do examples. And I've got 2 examples for you. Okay. And so let's start here with example 1. Okay. We're going to solve by completing the square. Okay, and so we're going to solve x squared minus 16x equals negative 15. Okay, now normally I would tell you, oh, you need to set it equal to 0. But when you're completing the square, it's actually helpful if your x terms are on one side and your negative 15 is on the other. There's a way for you to do it where it's set equal to 0, but this is actually a little bit easier for us, and I'll show you why here in a couple steps, okay? So the first thing that we need to do is we need to create a perfect square trinomial over here. Okay, so we need to find a C value that would make this factorable, okay? And we do that by doing B over 2 squared. So we've got B, which is negative 16, divided by 2, which is negative 8 squared, which is 64. Okay, so we're going to have x squared minus 16x plus 64. But here's the thing. You've just changed what we've done. You've changed the problem. You have an additional 64 on that left-hand side. So we're going to use the really awesome rule in math that whatever you do to one side, you must do to the other. And now you haven't changed essentially anything because you've balanced the equation back out. So remember, you can do whatever you want to as long as you do it to both sides. Okay? And now we can factor this side. So this turns out to be x minus 8, x minus 8. And negative 15 plus 64 turns out to be 49. Okay? And now you're probably like, okay, what do we do now? Well, remember that whenever you have a binomial like this, you can write it as something squared, right? And now you've got a problem that looks like something from 9.4, and you can actually now use the square root method. So you take the square root, you take the square root. And now you're left with x minus 8 equals plus or minus 7, because the square root of 49 is 7. And so now we can set up 2 equations. X minus 8 equals 7, or x minus 8 equals negative 7. And then we solve because it's linear. X plus 8, x plus 8. So x is equal to 15. And then add 8, add 8. So x is equal to 1. And so there are your 2 answers. And you could check those by plugging them back in or using your graphing calculator. And you're probably like, well, Ms. Bogdan, this is a lot. Yeah, it is. Welcome to Honors Algebra. Okay, let's do one more because I feel like we need some more practice here. Let's look at example 2. In example 2, we're going to solve by completing the square again. And this time we're going to go back to our original problem of x squared plus 6x minus 10 equals 0. Okay? Now notice that this one is set up already equal to 0, and this one is not. Okay? So we're going to actually make this problem look like this one by adding 10 to both sides to get that 10 out of the way. Okay? So we're going to have x squared plus 6x equals 10. Now it looks like the problem from above. So now our goal is to create something that can be factored over here. Okay? And so we take our b value, we divide it by 2, and then we square it. And our b value here is 6. 6 over 2 is 3. And 3 squared is 9. So the number that we're going to add over here so that we can factor it is 9, but whatever we do to one side, we must balance it out by doing it to the other. Okay? And then we can factor. So now we've got x plus 3 and x plus 3, and that equals 19. Okay? And then that's the same thing as x plus 3 squared equals 19. And so now we can square root. And so now you're left with x plus 3 equals plus or minus the square root of 19. And you're like, well, Bauckham, but 19 doesn't simplify, right? The only factors of 19 are 19 and 1. And I'm like, well, yeah, you're right. So we're going to still set up two equations. X plus 3 equals the square root of 19. And x plus 3 equals negative root 19. Okay? And then we're just going to subtract 3. Because this is a square root and that is not, you cannot combine those, so we're just going to keep that as the square root of 19 minus 3. And then we subtract 3, so this one turns out to be negative square root 19 minus 3. And that's how you leave your answers. You can't do anything there. Okay? All right, that should be enough to get you started on some homework. We're going to talk more about this in class. We're actually going to spend 2 classes on this. So come with your questions ready. However, if you're still confused on this whole b over 2 squared thing, go back and watch the beginning of that video again. I promise you might not get all your questions answered, but it will at least make a little bit more sense. Okay? All right, good luck. I'll see you in class.